this little tidbit is to show that driving Freescale's PCI Express clock inputs on their processor families like QorIQ, Layerscape, and IDT is not a problem with the PCI Express clock. The apparent issue comes in when you're investigating the spec and you see that the Freescale clock input requires a maximum input high voltage of 800 millivolts. And you look at a PCI Express clock and including overshoot, the maximum input high voltage is 1150 millivolts. So that's 350 millivolts higher than the spec for the Freescale part. However, it's really not an issue, and here's why. The PCI Express clock with this specification is defined with the terminations at the driver. And the load in this case is open, there's no termination there. However, the Freescale clock input has terminations at the receiver, so the load is terminated. And so in this case, what we have is what's called a double terminated environment. Really, the only impact of this is that the amplitude of this clock will get cut in half. And we see then that if we go with the 1150 millivolts for the PCI Express clock, we cut it in half, we end up at 575 millivolts is the highest voltage we'll ever see, and that is less than the 800 millivolts the Freescale part requires. The Freescale part also on its differential clock input has a minimum voltage of 200 millivolts. So with due diligence, we can look at the PCI Express clock, which has a specification of 660 millivolts as the minimum output high voltage that it will receive. And so if we look at 660 in this double terminated environment, that gets cut in half to 330 millivolts, which is above the minimum requirement of the Freescale part, which is 200. And you can see then that everything is fine. A PCI Express clock in the double terminated environment will provide a voltage between 330 millivolts and 575 millivolts, which is well within the range of 200 to 800 required by the Freescale part. So there is not an issue.